All right, so we've dealt with function equations with domain and range. Now let's go ahead and take a look at actually equations itself, and then actually telling what the domain would be without actually working it out or graphing it out, but actually just looking at the function and doing something to it to figure out what is your domain. Now, there's three types of functions that we're going to deal with here right now. Later on, we'll talk about other functions, but for right now, we're talking about, first off, a single line function. Now, a single line function can be any type of function that's pretty much we call a power function of some sort. So, for example, let's say we have like x to the fourth plus 3x squared minus 2x. Here, your domain will be all real numbers. Or we call them all reals. Or we do an R like this. And if you need to rewind the video a little bit to see how I did that R, do that again, and then you'll see that that's what we have for that. That's what we call it, all reals. But if we were to take a look at our interval notation version of it, when we talk about all reals, that means it's going to go on forever and ever from both directions. So negative infinity to positive infinity. So it goes on forever and ever. Completely never stops. Never stops. Never stops. So single line functions are easy. There's no work to it. You can just see it. There's no fraction here. There's no square root. There's nothing else weird going on there. It is just a single line function. Power function. Okay. Now, the second one is a fraction function. Now, whenever we have a fraction function, that's something like, for example, f of x equals 1 over x. A fraction function, something like that. Or it could be even more elaborate. And we're going to talk about that example too, something that's even more elaborate. But what you have to do here is you're going to set the denominator equal to 0. And we're going to solve for 0. Solve for the variable. My fault. Oh, let's erase that part. We need to erase it. Oh, I don't need all that. Erase. There we go. So once we actually set it equal to 0, and we're going to solve for the variable. Let's see if I can actually turn these over. So I set it equal to 0, and then we solve. There we go. We solve for the variable. Okay, so with that, your answer would always be for these functions. It'll be all reals except what x equals, or what the variable equals. So once you solve for the variable, whatever that variable equals, you're going to say all reals except that answer. And again, just because we're dealing with x here doesn't mean we're always going to deal with x. It could be other variables. It could be a t, could be a q, could be a y, could be anything. So again, it's not going to always be x equals, but for right now, that's what we're looking at. All right, and then our last one is a square root. And here for square root, we're going to, hopefully you remember your parts of a square root function. I hope. Parts of a square root function. There's an index number and there's a radicand. So here, underneath the radical here, just as a quick review, Whatever's underneath the radical here, this is considered your radicand. And I'm not making up a word if you haven't heard that before. It's your radicand. You will find that if you Google it. So what you're going to do is take that, whatever's underneath there, and we're going to set that radicand less than or equal to 0. Because anything that's underneath this, underneath the radical, whether it's square root or any even root number, or even index here, that's your index number there. Any number that's even, the number underneath the radical cannot be a negative number. So here, whenever we do this and solve it out, we're going to say our answer is going to be all reals except the answer you get here. Except the answer, whatever you get from up here. From this part right here. So it's going to be all reals except whatever answer you get right here. Okay, so that's your preliminary information. So now we're going to use that for our next example, example 2.